Hi there and welcome to this video. Thanks for clicking on and watching. Hopefully you're doing so because you're sitting Maths Edexcel A-level this summer and paper 1 is on the 7th of June. So here is the list provided by the exam board of topics to focus on for your revision. They have said this isn't the order the questions appear and some parts of the questions may involve other areas of the syllabus, but this is the main area for focus. So I've made another video and this one is just focusing on the top half of these topics. So let's get started. Hopefully you are finding things like this video helpful. It is easier to follow along on the screen with somebody rather than trying to read through solutions in the textbook. Do remember that my solutions aren't the only way to do questions, so you could find full mark schemes in the topic tests. Do like and subscribe if they are useful and keep an eye out for some more videos that I post. And do remember that in the description, if you just use the drop down arrow, there are timestamps. So if there's a particular topic that you just want to focus on, you can just use those to go directly to that topic. Okay, then let's get started. So here's my question 1. It's a proof question. It says question 10 because it's taken from the exam board topic tests. The exam board have provided these topic tests which they say best align to the style and type of question in the actual exam. So would say have a look through all of those. There are different ways to do this question, so full mark schemes are with the topic tests. I'm going to do this one by exhaustion. So for part 1, we've got to prove that if n belongs to the natural numbers, that when we square it and add 2, then the result is not divisible by 4. So by exhaustion, I'm going to cover all cases and say that if n is even, and say that n is equal to 2m, which will ensure that it is even, that when we square it, 2m squared and add 2, we're going to get 4m squared plus 2. This is not divisible by 4, as 4m squared plus 2 all over 4 is going to equal m squared plus a half. So m was our integer that we fed in, and having that half remainder, when we divide by 4, it's not going to be divisible by 4. And then if n is odd, then n would be equal to 2m plus 1. So when we square that and add 2, we're going to get 4m squared plus 4m plus 3. This is not divisible by 4 because we're going to get 4m squared plus 4m plus 3 all over 4, which is equal to m squared plus m plus 3/4. So again, that 3/4 means that it's not divisible by 4. So that's part 1 done. Part 2. Now again, there's different ways to do this. I would probably tend to go for the graphical method, but you could do an algebraic method or you could do a logical method. But what the question says is, given that x belongs to the reals, then when we take the mod of 3x minus 28, it's greater than or equal to the value of the same x take away 9. So I would do a graph. Now the mod graphs, the mod lines just mean that when you've got anything in between it, you just read it as its absolute value and you just take it as the positive value. So it's not going to be a problem until the graph of 3x minus 28 goes under the x-axis. So it's going to be gradient 3, it's going to come down, it would continue on and go through minus 28, but then the mod just means it would be reflected and it would come up here at 28. And then the graph of x minus 9, well, that's not got any mod lines, that's just the graph, and it would go through at minus 9. It wouldn't be as steep, but it would go through something like that. So you can see that they're going to cross, and at what point are they going to cross? Well, this point here on the line y equals x minus 9, when y is equal to 0, x will equal 9, so it goes through there. This mod graph, this line on this side of the mod is going to be 3x minus 28, and on this side it's going to be minus 3x plus 28 when you reflect it. So it would be useful to know these 2 points here. So I'm just going to equate both sides of the mod to the x minus 9 graph. So let's do 3x minus 28. Where does that equal x minus 9? So it would be at 2x is equal to 19. So x is going to be 9.5. So that point there is when x is equal to 9.5. And then if we do the other one, minus 3x plus 28, where does that equal x minus 9? You're going to have 4x is equal to 37. So x will equal 37 divided by 4, which is 9.25. So that point there is x equals 9.25. So you can see that there the graph shows it's after the 9 where it crosses through the x-axis, so it's all making sense. So where is the graph, the mod graph, greater? It's going to be when x is bigger than the 9.5 and x is less than, because this mod graph goes bigger than the line. So state giving a reason. If the above statement is always true, sometimes true, never true, it's going to be sometimes true. It's going to be true for when x is greater than or equal 9.5, or when x is less than or equal 9.25. This next question is an example of understanding and using functions in their graphs. So here we've got a graph and it's given as a piecewise function. So for x less than or equal to 2, we've got this part of a quadratic curve. So this place here must be 2. So when x is less than 2, it uses this function, and when x is bigger than 2, we've got a linear straight line. So find the value of g of 0. So you start with the one nearest. So when x is 0, well, when x is 0, we're following the quadratic function. So putting in the x is equal to 0 into the top quadratic question. So when x is equal to 0, g of 0 will equal, just going into that top one, nothing minus 2 will be minus 2 all squared, which is 4, and add 1 is 5. So then that will tell us that this is crossing here at 5, and now we need to do g of 5, because when we're doing it again, you've got to put the answer that you've just got back into g. Well, now we've got the answer 5, we're going to go in this second one. So when x is 5, you're going to do 4 times 5, 20. Take away 7 is going to be 13. So that means that it goes through here at 13. So g of 0 is equal to 13. Okay, part B, we're being asked to find x values for which g of x is greater than 28. Now remember, g of x just is the same as y. So if we draw a line here at y equals 28, if we find the x value where they meet both of those different sides of the function, then we can see that g of x is going to be bigger than 28 for x, going to be bigger than that value, and it's going to be bigger than 28 for x less than that value. So we need to find where they meet. So when x is bigger than 2, we're using this function. So where does 4x minus 7 equal 28? When 4x is equal to 35, so x will equal 8.75. So that is the point 8.75. So when x is bigger than 8.75, g of x is bigger than 28. Let's do the other one. We're doing b here. We've got x minus 2 all squared plus 1. Where does that equal 28? Now this is kind of in completed square form, so rather than multiplying that out and taking everything over and maybe using the quadratic formula, we will just go x minus 2 is equal to, take that 1 over, will be 27, and then if I just take the square root, and so then take the minus 2 over, it'll be 2 plus or minus root 27. Now it makes sense that we're going to get two answers because you have actually got that quadratic, you've just got this section of it. So obviously the 2 is going to be there, the 2 plus the root 27 is going to be the other one on this side. We actually want the one on this side, so x is going to equal 2 minus root 27. So we can simplify that third and say it's 2 minus 3 root 3. So I do it here. When x is less than 2 minus 3 root 3, then g of x is going to be greater than 28. Okay, part C. H of x is just going to be the same as our function, but it's just going to be that quadratic part of the function. So it's just this section here of the graph, and it's asking us to explain why h of x has an inverse but g of x doesn't. So g of x is this sort of piecewise function that is a many to one function, but h of x just being one side of it, h of x is 1 to 1. So that is why the h of x will have an inverse, because it's only 1 to 1 functions that have inverses. So h of x is 1 to 1, so we'll have an inverse. G of x is many to 1, so will not. Okay, part D. The inverse function for h is equal to minus a half. We've got to solve that equation. So where does the inverse function? Now if you think of functions, if I just do like a mapping diagram, if this is h of x gets us to the answers, and then the inverse functions get us back, we're saying what x value gets us from the inverse function back to minus a half. So minus a half must be in there to go forwards to get to the inverse function to then come back and get back to itself. So what we're really doing is trying to find h of minus a half, and that will actually solve our problem. You can find the inverse function and equate it to minus a half, but that is a little bit more of a harder job. So let's just do it this way. H of minus a half, well, we already have h of x, so all we need to do is put it in there. So that is going to be minus a half minus 2 all squared plus 1. So that's minus 5 over 2 all squared plus 1, which is going to be 25 over 4 plus a whole one, which is 4 over 4. So that's going to equal 29 over 4. So x is going to be 7.25. This next question is an example of using the intersection of points. So we've got y is equal to 3 times 2 to the x, and it's meeting a curve with y is equal to 15 minus 2 to the x plus 1. So you don't need to draw their graphs. It is asking us to find, using algebra, the exact point where they meet. So let's say that 3 times 2 to the x is going to meet when they're equal. Now what can we do with this 2 to the x plus 1? If you think about your rules of indices, if you've got 2 cubed times 2 squared, you're going to add those indices, and that would be 5. We've got an addition here, so we can say that is 15 minus 2 to the x times 2 to the 1, and that would cause us to add these two up and give us the x plus 1. So now we have got two lots of 2 to the x and it's minus that, so all that term can go to this side and we would have plus. I'm just going to put the 2 in front. When you're timesing thing, order doesn't matter, so I'm going to say 2 times 2 to the x, taking that term to the other side, plus 3 times 2 to the x is going to equal 15. So how many lots of 2 to the x have you now got? 5 times 2 to the x is equal to 15. Now 2 to the x is going to equal 15 over 5, 3. So when you're doing logs, 2 to the x is equal to 3. Another way to write that is log to base 2 of 3 is equal to x. So 2 to that power equals the base. So when you're doing logs, the answer to the log is the power. So x is going to equal log to base 2 of 3. This next question is a functions modelling question. It's also a differentiation question, and it's also an iteration question. So those are all on the paper 1. So we've got here the graph H of a roller coaster during its first few seconds, and in part A we're being asked to differentiate H. Now I've just written out H again here because it's quite difficult to read. We've got minus 0.3 and then t minus 6.4, and the other power is 0.8 t minus 6.4. Now how do we differentiate e to the kt, where k is just a constant? It differentiates to k e to the kt. So we have to just think, when this minus 0.3 multiplies in, the coefficient in front of t, which will act like the k, is going to be minus 0.3. That has to come down and times by the minus 10. So when we're doing the differential, you're going to get minus 0.3 times minus 10, which is going to be 3 e to the minus 0.3 t minus 6.4. So when we differentiate e, that just repeats itself, it's just the same. And then the 0.8 times by the minus 10 is going to be minus 8 e to the 0.8 t minus 6.4, and then the constant, the 70 on the end, is just going to go out. So that is the differential of h. Now in part B, show that the differential is 0, then t can be equal to this equation here. So notice that we've got t and we've still got t in here, and we're trying to get h dash of t is equal to 0. So that's going to be when we have a turning point. So that's going to be at A, and later on in the question we're using the iterative formula, which is the thing we've just proved here. So when you have iteration, what you are doing is trying to make one of the t's here, when we equate this to 0, one of these t's, you make that the subject. So we can see that we've still got this e to the minus 0.3 in our equation for t, so it must be this t that we are making the subject. So what we're going to do is do 3e to the minus 0.3 t minus 6.4 and take this term to the other side. It's going to be 8e to the 0.8 t minus 6.4. I'm going to divide by 8, so 3/8 e to the minus 0.3 t minus 6.4 is equal to e to the 0.8 t minus 6.4. Now we're going to take ln's to both sides. Now because of this 3/8, you can't just then go to that power. You'll have to keep that all as one term. So it's the ln of 3/8 e to the minus 0.3 t minus 6.4 is equal to, now on the right hand side you can just say it's the power because you just got e on its own, so that's 0.8 t minus 6.4. And now 0.8 is 4/5, so if we just cross multiply, that's going to be 5/4, the ln of, we can say it's 3e to the minus 0.3 t minus 6.4 all over 8, just making it look more like what we've got here, and that is equal to t minus 6.4, and then all we need to do is take the minus 6.4 over, so it's 5/4 the ln of 3e to the minus 0.3 t minus 6.4, and then plus 6.4 is equal to t. So we have done it. Now it's saying use this formula here to find t, to get a t that's going to be when h dash of t is equal to 0, we're going to be at the turning point. So it's asking us to use t0 equals 5, put it in our calculator, get t1, t3 to 4, etc. to 4 decimal places, to try and find an estimate for the t at that turning point, because we are putting it into h dash, so we're trying to find the t when it reaches its maximum height there. So it's quite, you need to do 5/4 and then put all this in your calculator. But in your calculator, if you have in and have put in 5 and get 5 in the bottom of the screen, and then feed this expression in using the ln, and then use your fraction button, and then where you're putting t, if you just type in ants, then whatever's in the bottom of your screen will be read as the answer, and you can just keep pressing the equal sign, and then out will come all these approximations for t that you want using this iteration formula. So if you do all that, you'll get t1 is equal to 5.6990. Then if you press equals again, t2 is 5.4369. T3 is 5.5351, and then T4 is equal to 5.4983. So they're all to 4 decimal places. Then in part D, that was C, part D, by choosing a suitable interval. Now show that the t coordinate of A is 5.508. So this is what it's giving us as the t coordinate of A, where we've got our maximum point. Choosing a suitable interval, you always go to one more column along and go half above, half below. So if we put h dash of 5.5085, if we put that in, we get minus 0.00072. And if we do h dash of the lower root, 5.5075, so going half above in that column either side of this t coordinate of A, if we put 5.5075, we get 0.00360, and here we've got a change of sign. Now what have we been putting this into? H dash, so it's the differential. So the change of sign means that we have got a change of gradient. So change of gradient. And if we've got a change of gradient, this is implying we have a turning point. So we have found the max. It must have a turning point at A. This next question is a circle geometry, and we're going to be calculating arc length in part B. So we've got circle 1, which is centered at the origin, and we're told x squared plus y squared is 100. Well, the equation of a circle, x squared plus y squared is r squared, so we know that the radius is going to be 10. In the other one, the equation of a circle, which is not centered at the origin, is x minus a all squared plus y minus b all squared is equal to r squared, where a, b is the centre. So you can see here this minus 15 means that this circle has got centre 15. The y on its own just means y minus 0. So the coordinate of the centre for C2 is going to be 15, 0. And again, we can put in the radius. The radius is root 40. Now we're being asked to find and show that the angle AOB is 0.635. So AOB is 0.635 is that angle there. So what we need to do is find where A is and just work in a right angle triangle here. And then we can just double it up from the symmetry of the two circles. We can just double it up and find the 0.635. So we know that that is 10. So in order to find this bit here, we're going to find the x coordinate where those two circles meet. Now, because we've got the C1, which is centered at the origin, it's a bit easier to say that in circle 1, y squared is going to be 100 minus x squared, and where they meet, we're just going to substitute that in for the y squared there. So C2, where they meet, is going to be x minus 15 all squared plus y squared, which we're now saying is 100 minus x squared, and that's going to be equal to 40. Squaring out the bracket, x squared minus 30x plus 225 plus 100 minus x squared is equal to 40. The x squareds will cancel. 225 plus 100, take the 40 over, is going to be 285. The minus 30x on the other side will be 30x. And if you divide by 30, x is equal to 9.5. So that distance there up to where they meet is going to go in our triangle there. This is O, A, and the x-axis. Now, because we've got to find this angle and then double it up, the 9.5 is the adjacent. So if we do cos to the minus 1 of adjacent over hypotenuse, inverse cos of that is going to be 0.31756. And so angle AOB is equal to 2 times 0.31756, which is our 0.635 radians. So that's part A. Part B. The region is shaded and bounded by C1 and C2. Find the perimeter of the shaded region. So the perimeter is all the way around the outside. We need to find the arc length of there, the large circle, and we need to add on the arc length of the smaller circle. Now we've just found that the angle here is 0.635 radians. So arc length, when you're in radians, is equal to r theta, and the theta that gives that arc length the size is this angle here. Now all the way around is 360, but in radians that's 2 pi, and if we take off the 0.635 radians, all we need to do is that angle and then times it by r, which is 10. Now, when you're doing some questions, sometimes they are sort of leading you a little bit of what to do. In part A, we had to find that angle, and then that's telling us how to find that arc length. So in part B, when we're trying to find the perimeter, what we need to do is exactly the same on this smaller circle and find this angle, take it away from 2 pi and do arc length on that one as well. So if we look at this triangle here, which is in the smaller circle, so going A. Now here, that is 15 along the x-axis, and up to here, when we went from the origin, this was 9.5. So 15 take away 9.5, the actual adjacent to that angle is 5.5, and we know that this is root 40, so we want to find this angle. This bit here is 9.5 there, sorry. And that bit there is 5.5. So again, inverse cos of 5.5 over, why have I written root 10? Root 40. And that is going to be 0.5164. So angle that we're after there is going to be 2 times 0.5164, which is 1.0327. So then the angle in order to find the arc length is going to be 2 pi minus the 1.0327, and then we can find the perimeter. So the arc length of C1 is going to be our R, 10, times our 2 pi minus the 0.635. Now if you do that, that comes out to be 56.48. And then arc length C2 is going to be, again, these are r thetas. So r is root 40 times 2 pi minus the 1.0327. If you do that, it comes out to be 33.21. And then the total perimeter is those two added together. So 56.48 plus the 33.21 comes out to be 89.7 to 1 decimal place. This is an arithmetic series question, and when you do an arithmetic series you have A as the first term, so it's telling us here that A is 16. Now when you have an arithmetic series or a sequence, you're going to have A and then A plus D, A plus 2D, with D being the common difference. So D doesn't start until the second term. So by the time you got to the third term, you've only got 2D. So when you get to the nth term, you're always one behind in the amount of D that you've added on. So A plus n minus 1D will be the nth term. So here when it's telling us the 21st term is 24, that's going to be A plus n minus 1D, where A is 16 plus 20 lots of D, and that's equal to 24. So all we need to do is to solve that. 20D is going to be 8. So D is 8 over 20, which is 0.4. Hence find the sum of the first 500 terms. The sum of the terms formula is n over 2, 2a plus n minus 1d, and n is 500, the number of terms, so we just put those in. A was 16, double 16 is 32, n minus 1, so 499, times d, 0.2, and if you put that in your calculator, it comes to 32,950. Easy, 4 marks. So here is another arithmetic series question, but this time we're given the terms in terms of some algebra in terms of k. We've got to find the number of terms in this series if it starts with k plus 1 and ends with 303. So a is equal to k plus 1, and then we're going k plus 1, 2k plus 3, and so on. So we can find the common difference by seeing what do we get between the terms. It's going to go k plus 2. We can check that. The next term along would be 2k plus another k, 3k, and then 3 plus 2, that would be 5. So that works. By the time we get to the last term in this series, we've got 303. Now we're trying to find how many terms there are. So that's what is n. So we've got d is equal to k plus 2, and we want to find n. Now there's a couple of ways you could do this if I go over both of those ways. One way would be to split the sequence into its different parts. It's got a k part and then the numbers part. So if we just looked at the k's, it would go k, 2k, 3k. Now for the first term it's 1k, 2k, 3k. So for the nth term it would actually be nk. And then in terms of the numbers it goes 1, 3, 5. So by the time we get to here, it will be, because this is a arithmetic sequence, it would be 2n minus 1, because this is just the 2 times table down one. Now those two parts add up to the 303. So we've got nk plus 2n minus 1 equaling 303. So we have nk plus 2n is equal, take the minus 1 to the side, 304. Take n out as a common factor because that's what we're trying to find. That's going to be 304. So n is equal to the 304 divided by the k plus 2. So that's one method of doing it. The other method would be a plus n minus 1 d is equal to 303. We know that a is k plus 1. We're interested in n, but we don't know what it is, so we just have to leave that as n minus 1. We do know that d is k plus 2, and that's all equal to 303. So multiplying those two brackets together, you're going to get nk plus 2n minus k minus 2 is 303, and then adding them all up, you've got a plus k and a minus k, so they will cancel. You'll have the nk plus the 2n, but then minus 1 is 303, which is exactly what we got down here. So that's also going to give us that n is 304 over k plus 2. Okay, so you'd only need to show one method, but just whichever way you look at it and see it, you could sort of do one of those methods. Right, part B, show that the sum of the series is this. So the sum of the series is going to be, now there's two versions of the sum formula. You can have n over 2, 2a plus n minus 1d. Now this bit in the bracket comes from the fact that we have a plus n minus 1d. Just having those 2a, we can split that up because this is the nth term, and we know that the nth term is 303. So I'm going to use this version, which is really n over 2 a plus l. The first and the last term is a simpler version of the sum formula. So we need to say what that is. So it's going to be n, which we know is r3 over 4 over k plus 2. And then this 2 will just join in here. And then we've got a, which is our first term, k plus 1, and our l is 303. So if you half 304, you get 152 over k plus 2 into k plus 304, adding the 1 and the 303 together, and that comes to 152k plus 46208 over k plus 2. So that is what we were after. So part C, or we're going to do that, I'll do that up here. Part C, given that the sum is 2568, we can say that 152k plus 46208 over k plus 2 is equal to 2568. Cross multiply 152k plus 46208 is equal to 2568k plus 2. So if you multiply that out, take everything to one side. So take that 152k to that side and bring the 2 times the 258 to this side. You will get that k is equal to 17. Thank you so much for watching. If you're still with me at this point, hopefully you have found that useful. So do give it a like and subscribe. Good luck with your revision and your exams this summer, and I will see you on the next one.